Hello everyone. Hello everyone. Welcome to week 2 programming with C++. I'm very excited to continue our journey into the world of C++ programming with you today. Last week you covered the basics of C++, and this week we are going to dive deeper into one of the most fundamental concepts in programming. That's the data types and declarations. Data types and declarations. Think of data types as the building blocks of your programs. They determine what kind of information your program can work with and how that information is stored in memory. So for this week, our learning objectives, we should be introduced to C++ types. We will learn the fundamentals types such as the booleans, the character types, the integer, the floating point, the void, and the sizes. We also learn about the declaration. We learn about the structure of the declarations, declaring multiple names, the scope, and initialization. Yeah. Well, let's begin with data types. Let's begin with our data types. When we talk about data types, what are they? Let's talk about data types. Let's start with the basics. What are data types? Data types refers to the various forms data can be represented in the language. Various forms that data can be represented in the programming language. Think of data types like different containers in your kitchen. You have containers for liquid, solids, containers for small items, and containers for large items. Each container is designed for a specific purpose. In programming, it's same for data types. They work the same way. They tell the computer what kind of information you are providing or you are storing and how to handle it. For example, you handle whole numbers differently than you handle these decimal numbers. So, an example of a data types, we have the integer, we have the float, we have the boolean. Yes, so that's as we move on, let's move to the categories of data types. Our categories of data types. We have the integers, we have the integral types. The integral types include the integers, characters, then booleans. Yeah, they are all types that represent whole values or discrete choices. The second one that we have here is arithmetic types, which include both integral types and floating point types. These are types you can do math with. We also have the user-defined types, which include enumerations and classes. These are types that you create yourself for a specific purpose. We have the built-in types, include fundamental types, pointers, and references. These are types that C++ provides ready-made. You don't worry if it seems overwhelming. We will cover each category in details. And we also deal with practical aspect, as you have seen. I've opened or I've launched my code blocks, which will be doing for our practical. But let's wait a bit and let's deal with the theoretical aspect. Let's deal with the theoretical aspect first. Now, understanding data sets. When we talk about data sets, what are they? Data set specifies the range of values a data type is composed of. Each data type has its data set. Let's look at an example of a set as the integer. The integer data types can hold whole numbers that are both negative and positive, including the zero. We also have the floating point. The floating point data type can hold decimal numbers with single precision. Example as the 3.14, negative 2.5. We have the double. The double data types can hold decimal numbers with much higher precision than the float. So the key difference between the double and the float is that the double is accurate. Double can store more decimal places. Let's continue with our character. We have character. Our character data type can hold numbers, letters, and symbols. Yes, then we have the boolean data types. Also can hold two values, which is a true or false, yes or no, one or zero, on or off. We have the string. The string data types can hold combination of characters, essentially text. Essentially the text, which is the hello, hi. Now, understanding data sizes. Part 2, let's talk about data sizes. We talk about data sizes. The data sizes specifies the amount of memory a data is allocated in a data type. Each data type has its data size. So using the keyword size of, you know the size of your fundamental data types that you are using. So let me break down some data types for you. You have the integers, the sizes. The integer uses 4 bytes. 4 bytes, this is enough for numbers from about -2 billion to +2 billion. You have the float. The float also uses 4 bytes, but stores decimal numbers with about 7 digits of precision. 7 digits of precision. You have the double. The double uses 8 bytes, which also stores decimal numbers with about 15 digits of precision. You have the character. The character uses only 1 byte, the smallest unit. It's perfect for single letters or symbols. Our boolean also uses 1 byte. 1 byte, even though it only needs to store true or false, yes or no, 1 or 0. It uses a full byte for efficiency. Our next is string. The string uses 32 bytes. This is for storing object itself. This is for the string object itself, not including the actual text content. Now let's move into details. Let's break these things down. Our data types. Let's take them one by one. We are beginning with our integers. But before that, let's launch our C++ code blocks. Now, as you can see, we've launched our code blocks. We will move to create new project here. Then you come to console application, double click. Then you click on next. You type in the name of your project. I'll enter my name, Sorry here. I'll click on enter. Name already exists. Okay. Sorry, then I'll enter another name which is hello. Enter hello here. I'll click on next. Okay, make sure the compiler is this GNU GCC compiler. Then click on finish. To be like this, then you move to your management page, which is the left page. Click on it. Click on the main CPP, main.c++. It will give you a page containing the basic structure of a C++ language. So this is the hashtag include IO string. We spoke about this last week. This is the username space. We spoke about this structure last week. I hope you remember. So today we are dealing with this integer aspect and overview. So for the integers are whole numbers. No decimal point is allowed. Important rule for the integers is the positive integers don't need a positive sign. We don't use commas when writing numbers for integers. The commas are only used for separating items in lists. So integers are perfect for counting things, storing ages, or any situation where you need whole numbers. So let's do an example for this. An example for this, we'll talk about our int main here. We'll click on enter. Something like int ring x. Here you assign it as equal to enter 25. You terminate with this, then you click on next. As let's say hello, then ring here, ring the x here, this, then you terminate. So let's run this code and see what is going to be here. And so output we have hello 25 here. So the integer number that we use is 25, and we've seen the output here. That's what we do with integers. Now let's continue to our next data types that we have here. We have our next data type here is the floating. But take note, the int keyword tells C++ that you want to store an integer, and you can assign values immediately or later. You can assign values immediately or later. So now let's move to our float. But before that, let's terminate this code. Okay, sure. Hey, let's comment this code. We are moving to our float. So our floating points data types are used to represent numbers with decimal points. Think of them as numbers that can float a decimal point to different positions. We have 3 different types of floating points. We have the float at a single position about 7 decimals, and we have the double position about 15 decimals, and we have the long double, which is the extended position, even more precision. That's the floating point. For most applications, the float and double are sufficient. We use float where memory is tight and you don't need high precision, but we use double when you need more accuracy for your program. So let's do some practical aspect here. Let's try float amount equal to 12.72, then you terminate. Then we will come here, enter amount here. Here will also be amount. Then run your code. Realize amount 12.72. But before that, let's create some space in between this. So we will have something like this, then run this. Let's see, there will be a space between it. Okay, now you can see clearly there's a space here. So now our amount is 12.72. So that's our float, 12.72 amount, 12.72. That's for the decimals. Our next data type, we have the double. Let's try the double also. We have the double here. Let's comment on this. So we have a double. We are going to talk about. Double like double. Talk about distance equal to Sorry. I use grade instead of the gender, so let's change it to grade. Our grade here. Let's also grade. Grade here. Let's run it. Okay, our code is now out. So you can see grade is A. So your grade is A. That's how to use that character. Now let's move to the string. Our string, when talking about strings, when we talk about strings, our string character, our string data types. But you should note, for the character, we use single quotes, and for the string, we use double quotes. So strings are a programmer-defined type that's applied in the standard library. Think of a string as a sequence of characters grouped together. Key characteristics of strings are they can contain zero or more characters that are enclosed in double quotes, but an empty string is also called a null string. You should note, an empty string is also called a null string. And each character in a string has a relative position. First position, we begin with 0, 1, 2, 3, and so on. So this is how strings work. We start with string and be like name equal to, then your double quote, let's say Amma. Then you terminate with this, and you come here. Name is, then here name. Then you run your code. See the name, so we have name is Amma. We have name is Amma. Name is Amma. Next is the void. Next is the void. For the void, it signifies absence of information. The void signifies absence of information. Syntactically, a fundamental data type can be used only as part of one of the complicated type, mostly used in functions. Void is most of the times used in functions. So with an example here, let's get an example. We have void outside. Let me try this an example. We have something like void my function functionary, something like this. See out. There I'm a boy. Then I end my line with this. Then you terminate. Then you come here, then you enter, and right here you just enter my function like this, then you terminate. Let's run our code and see. For taking write my function. Now let's continue with our next. For example, we have the signed and unsigned modifiers. Signed and unsigned modifiers. We have the signed modifiers. So the signed modifiers, they can represent both positive and negative values. This is the default for most integer types. And the unsigned Unsigned types only represent non-negative values. This allows them to store larger positive numbers since they don't need to reserve space for negative values. Think of signed as a thermometer. It can go above and below zero, and unsigned as a car's odometer only goes up from zero. That's it. We are moving next to our next data type. We have other fundamental types. So C++ also have other fundamental types with different sizes. That's the short. You have the short, which typically 2 bytes for smaller integers when memory is important. You have the long. The long is typically 4 bytes, same as integer on most systems. You also have the long, typically 8 bytes for very large integers. These types give you more control over memory usage and the range of values you can store. Use them when you have specific size requirement. The short, long for very big number, long for big numbers, and long for very big numbers. You also have the composite type overview. And that's the pointers, arrays, and reference. You have the pointers, arrays, and reference. The pointers are variables that store memory addresses. Pointers are variables that store memory addresses. And the arrays are the collections of elements of the same type. Reference types also just for existing variables. We will cover these things in future lectures. For now, just know that they exist and are built on top of the fundamental types we are learning today. We also have user-defined types overview. C++ also allows you to create your own custom types. That are the data structures and classes, the enumeration representing specific set of values. Enumeration. So we have enumeration, and we are moving to declaring multiple names. Sometimes it is used to declare several names in a single declaration. A declaration uses commas or comma for separation, mostly done for similar data types. Declaring multiple names, sometimes you need several variables of the same type. Instead of writing separate declarations, you can just declare multiple names in a single declaration using these commas for separation. This is not commonly done for similar data types and can make your code more concise. So let's see an example here. We have, when we are declaring, we can declare it as int x, then we terminate, int y, then terminate. Instead of doing these things, you can just do it at once and be like int x, comma, y, then terminate. This is also accepted. This method is accepted, and this is also accepted. They are all correct for you. So when declaring multiple codes, you can add something like float, you have weight, then comma, you have height, then you terminate. These are declaration. When you talk about initializing or assigning, that's when you come here, you initialize it as int x equal to 25. This is an initialization. We have int y equal to 30. We terminate initialization. We have the float height equal to 76.45. We terminate. That's also initialization. You've initialized your code. With initialization, you declare, then you assign. You assign your variable to a number or a data type set or data set. So here we assign our data type is int. We assign the variable x to the number 25. Same here. Here we use float height as a variable. We assign it with this. Then the whole thing declaring and assigning to a figure is what we call initialization. Now let's end our lectures with the understanding of scope. When we talk about scope, what do you understand by scope? Scope refers to the region of a program where a variable can be accessed. Think of the scope like the range of a wireless signal. It works within a certain area but not beyond. So you have an example or types of the scopes. The scopes, you have the local scope, which the variables inside functions or blocks. When we talk about a local scope are variables inside the functions or the block of scopes. And the global scope are always variables outside our functions. We have the class scope. The class scope are variables inside the classes. The name scope are variables inside the namespaces. We have the statement scope, variables inside specific statements. Understanding scope is crucial for writing organized bug-free code. Yeah, so let's see an example here. I say scope here, you type something like int to age that equal to 18. This is a global scope. It's outside the function. This is the function. The function is main, int main, the function. So declaring something like this outside the function is called the global scope. So this is a global scope. This is a global scope, as you can all see. And declaring the scope in the function as like this is what we call the local scope. So int x equal to this is what we call the local scope. So this is the local scope. So variable declaration explained. In C++, an identifier, you use an identifier to declare the variable. It's like introducing yourself before having the conversation. The compiler needs to know what you are talking about. That's the declaration. You declare variables. Yeah, as we are ending, talking about initialization, talk about declaration. We've done some little practical aspects of our programming language. The practical aspect of our programming language. We've covered the fundamental types such as Boolean, characters, covered the practical aspects of the Boolean, characters, and I hope you understood everything. You enjoyed our lesson. You enjoyed my lesson for today. You were introduced to declaration. You learned structure, declaration, multiple names, data types. You learned about integers. Now I encourage you to be doing practicals with this. When you learn, then you do practicals. To get better understanding. I encourage you to review the concept before our next session. You should review the concept before our next session, which is week 3. If you have any question, don't hesitate to ask me before our next lectures. Thank you for your attention, and I look forward to seeing you in our